Welcome back to our Pandas series. Today, we've got an urgent email from Panda Pizza's CFO. They want to investigate a mysterious spike in order amounts, and they've also heard a customer complaint about a specific order ID. Let's see how we can quickly locate rows, check single values, and even list out our top 5 biggest orders using loc, iloc, sorting, and more. We'll also talk about how to iterate over rows, though I'll explain why that's sometimes not the best approach. Let's dive in. So, these are the topics that we will be covering today. First, we'll take a look at indexing and selecting. We'll learn about .loc and .iloc as well as .at and .iat functions. Okay, and then we will take a look at accessing columns. We will both learn about using the bracket notation for accessing columns as well as the dot notation. After that, we'll take a look at sorting values in both ascending and descending orders. Finally, we will also talk about iterating through rows in a data frame using the .iterrows function. Let's get started. Hey there. So the context with which we are dealing today is that the CFO has asked for the top 5 orders. Okay, so we can see that because there's some anomaly. Okay, so we would want to check the pattern there. And then we also see that there is a specific customer complaint. So we may have a specific ID and we'll have to check the topping for that particular order. And our starting point is that we have a data frame df underscore orders from orders.csv, which we loaded yesterday. And it contains columns like order ID, customer ID, the price, pizza type, order time, etc. So let's get started. Now again, we are in VS Code and we are in our interactive Python notebook. Now again, let's start with learning something interesting, which is loc and iloc. If our data frame is indexed by order ID, if that were the case, again, we are taking a look at df underscore orders. So let me just see how it looks. So df underscore orders. So this is our data frame. Now, at the moment, you can see that it is not labeled by order ID. Okay, so you can see that the indices at this point or the names for the rows are 0, 1, 2, etc. Now, if we had used order ID as a label for the rows, then we could use loc to select a specific row. Okay, now let's quickly transform this. Let's change this and set the order ID to be the label for df underscore orders. So again, over here, notice the labels are 0, 1, 2, 3, etc., which is the indices. Now we are going to change this. So I can say df underscore orders dot set index, and I'm going to set the column with the name order ID, which is this column over here. So that's order ID as the index name. Okay, so that's what I'm doing over here. And then I'll also have to mention in place equal to true. Okay, because if I don't do that, let's also see that. Okay, that's a good chance to learn about that. Now, if I just do this, so it should be setting, as you can see over here, the order ID is set as the label name for each row. But if I again take a look at df underscore orders, you will see that it has not changed. Okay, so let's run this. And you can see that again, over here we have 0, 1, 2, 3, etc. Now, that is why it's important over here to mention in place is equal to true, so that whatever change we are doing over here would modify the data frame. Okay, so let's do that over here. So df underscore orders dot set index order ID, and then I'm going to say in place equal to true. Okay, now let's run this and let's take a look at df underscore orders. And you can see that df underscore orders over here, we still have 0, 1, 2, 3, etc. as the labels. Now let me go ahead and change this. I'm going to say df underscore orders dot set index order ID, and over here I'll say in place is equal to true. Okay, and when we do that, this has executed. Now let's take a look at df underscore orders. So I have another block over here, and I'm going to take a look at df_orders. And when I do that, you can see that the labels have changed and they stay changed. Okay. So that's why over here mentioning in place is equal to true is important. Now we will see this in the future videos as well. Like if you drop a column, for example, you'll have to mention in place is equal to true. Only then the change would reflect in the original data frame. So coming back to loc, which is what we are learning over here. So far, what the change that we did to df_orders is that we set the order ID as the label for the rows. Now, let's say this is the specific order ID where we received the customer complaint odd 0004. Okay. So again, it could be any order ID, but let's say the customer mentioned this particular order ID along with the complaint, and management wants us to pinpoint that particular order. So I can say specific order is equal to df_orders, and then I can say .loc, and over here I can specify the label of the row that I'm trying to access. And then let's also see how it looks at that moment. So if you do that, you can see that we get this particular order. We have the ID, the customer ID, the product ID, the quantity, the price, the date, etc. Now, if the indexing was the default indexing 0, 1, 2, 3, etc., which was the case for df_orders initially, like over here, then we could also use label based indexing on the column names. So let's see that as well. So let me quickly revert to this. So for that, I'll again read df_orders from the CSV, which is what we did a few days ago. Okay, so that's this over here. df_orders is pd.read CSV orders.csv. So I'm doing that. And again, the reason that I'm doing this is I want the indexes back as the labels for the rows. Now, if you can see, df_orders has 0, 1, 2, 3, etc. as the labels for the rows. Now let's take a look at how we could use label based indexing on column names. And again, let's say I want to locate this particular order 004, okay, ord 004. So what I could do over here is I could say specific order is equal to df_orders dot loc, and over here I will try to create a Boolean series that checks whether the order ID is the order ID which I want. Okay. Now again, we will see this multiple times, but first maybe let me write this and then we'll discuss this. So over here I'll say df_orders, and I'll say order ID, which is what we have over here. Order ID is equal to the order ID which I copied, which is ord 0004. Okay. Now when we do this, what happens is that this part over here, right, the condition over here creates a Boolean series of true and false for all the rows, and only the row where the order ID is this particular order ID will have a true value. And then every true value would be returned by this. Okay, so this expression. So specific order ID ultimately will have all the orders where the order ID is equal to this particular order ID, and because we just have one such order, we will be able to retrieve the specific order. So let's go ahead and take a look at whether this also works, and you can see that yes, it's working. We are getting this particular row back. Okay, so we have seen how we can use .loc or .loc to retrieve the details of a specific order. And this matters because let's say management says I want the row for this exact ID, then .loc or .loc is the intuitive choice because we are dealing with labeled indices or columns. Okay, so we have seen the case where we have labeled columns, which is this case over here. You can use this format to query that particular row, and if the rows themselves were labeled, which was the case over here, then we could access the necessary details in this manner. So we have seen how loc is a powerful function which we get along with pandas. Now let's go ahead and take a look at iloc, which is useful for positional indexing. Okay, now iloc is how we select rows by pure position. Like for example, if you want to select row 0 and let's say you want row 0, you can select that. Or if you want all the rows from row 1 to row 5, you can select it using iloc. So let's see how we can do that over here. So again, let's say first 5 orders is equal to df underscore orders dot iloc, and then over here I'll just specify colon 5. Okay, so if I do that, you can see I get back the first 5 orders. Again, let me write first 5 orders over here so that we can see how it looks like. Okay, so you can see that I'm getting the rows from 0 up to 5, but 5 is not included. So 0, 1, 2, 3, 4, 5. And if I wanted the rows from, let's say, 2 to 4, then I could do 2 colon 5, and you can see that 2 is included, but this 5 over here will not be included in the rows that we get back. Okay, so again, this is used when we want to select rows by pure position. So that's the use of iloc. Okay, so when it comes to the business case, we may use iloc if we just want to see, let's say, the first 10 rows quickly, or if we are splitting the data frame by numeric ranges. For example, you want to split the first 50 rows into a file and the next 50 rows into another file. In that case, you could use iloc. But for the CFO's request with which we are dealing in this video, loc might be more direct. Alright, so we have got introduced to loc and iloc. Now let's proceed and learn something new. Okay, so we are going to learn about at versus iat, which is used for accessing single values. Now imagine this. Let's say we need to check just one cell, like the total price of a particular order with a particular order ID. Instead of slicing the entire row, we can directly pinpoint that single value. And for that, we can use at and iat. Okay. Now, if you're using label based indexing, we would be using at. And for integer based indexing, we would be using iat. Now, let's see this in action. All right. Now, let's say I want to know the price of the order where the label for the row is, let's say, 3, which is the case over here, right? At this point, let's take a look at how our df underscore orders looks like. So let's just see that over here. So we have df underscore orders. Now, because we reverted back, the labels for the rows are numbers 0, 1, 2, 3, etc. Now, let's say for this row where the label for the row is 3, let's say I want to find the price, which is 48.31. Let's say I just want to pinpoint this particular value. Now, how can we do that using dot at? Let's take a look at that. So I could say price of the complaint order, okay, is equal to df underscore orders dot at. And then first I'll have to specify the row label. In this case, that's 3 because we have the number values 0, 1, 2, 3, etc., the indices as the row labels at this point. And then I'll have to specify the column name, which in this case is price. And when you execute this, and again, let's take a look at what we get back. So when we run this, you can see we get back 48.31, which is the price that we wanted to pinpoint, which is this price over here. Okay, so this is how you can use dot at. And if you just have integer based indexing, and again this over here is at 0, 1, 2, 3, 4, it's at index 4. Okay, so you could say price complaint, again let's just call it price complaint, is equal to df underscore orders dot iat, and then you can specify the index for the row and the index for the column. Again, we have seen that's 4, right? So after that, let's also print and see how it looks. And if you run this again, you will get 48.31. So this is how you can use dot at and dot iat. Okay, so quickly reviewing, if you have label based indexing, you can use dot at, and for integer based indexing, you can use dot iat. Now again, over here we have 3, but if we had the order IDs as the row labels, then instead of 3, we would mention that particular row's order ID. Okay, so again, this is for label based indexing. Now, what would be the business case for something like dot at and dot iat? Let's say the CFO says, I just want the exact total price for that problematic order. Then probably these methods give you lightning fast access without returning the entire data frame slice. Okay, so it's pretty useful. Now let's continue and learn something more about pandas, which is about accessing various columns and sorting columns. Okay, now there are two ways that you can access a particular column. You can either use the bracket notation or you can use the dot notation. So let's go ahead and learn these two aspects. Now again, let's say you want to access the price column of df underscore orders. You can do that using bracket notation by saying df underscore orders, and then you have this bracket over here, and then you can mention price, which is the column name. Okay, and then over here you can say df underscore orders, and let's run it. And you can see that you get back this column which has all the price values. Okay, so we have accessed this column using the bracket notation. Now how would you do this with the dot notation? Again, that's simple. You could say df underscore orders dot price. Again, it will do the same thing. If you run this code block, you get back this particular column. Now the dot notation may be slightly shorter to type but can cause issues if your column name is something like order dot type, or in this case price dot net. Okay, so again you can't say df underscore orders dot price dot net, and then if you have a space and all, the dot notation can be causing difficulties. So the bracket notation is often more safer to use. Now, if you again want to quickly check the distribution of total prices, you can use the dot describe method, which is something that we had previously discussed. So let's also quickly see that df underscore orders, and to access the column, again you can use the bracket method, and I'm mentioning price over here, and then you can say dot describe. Okay, so again we have used the bracket notation over here. You could do the same thing with the dot notation as well. So for the price column, which is a series data structure in pandas, remember we had discussed that in day one, every column in a data frame is considered as a series. So for that particular series, we have various things like the count, the mean, the standard deviation, the minimum, the maximum price, etc. Okay, so we have seen how you can access columns both using the bracket notation as well as using dot notation. Let's now proceed and learn about sorting values. Remember, the CFO's specific request was that we want the top 5 largest orders by total price. So what we could do is we can have another code block over here, and I can say top 5 orders is equal to df underscore orders, and then I can sort the values, sort underscore values, and over here I will specify, oops, this is blocking, yep, and over here I'll say by, and then let's give the column name, which in this case is price, and let me mention ascending is equal to false. Okay, so ascending is equal to false means it will be in descending order, and if you put it as true, it would be in ascending order. That's it, right? And then again I have dot head 5 because I just want the 5 orders. Remember, dot head is something that we had discussed in day one. So in this way I'll be able to get the top 5 orders, and then I can just print this. Let's say print top 5 orders. Okay, so let's go ahead and execute this. And you can see that these are the 5 top orders which we have. Okay, and you can see their prices over here as well, and it is in descending order because we have said ascending false over here. So this is the highest price, this is the second highest price, and it goes on in this manner. So in this way we have got the biggest orders which might highlight VIP customers or potential anomalies, which is what we are trying to investigate over here. Now again, you could mention ascending is equal to true over here, in which case you would get the lowest prices first, and probably a business case for that might be a case where you want to inspect suspiciously low prices that probably may indicate an error. Quite handy indeed. All right. So let's go ahead now. So we have seen how to access columns, and over here we have seen how to sort a column by value, and then we used the dot head function over here to just take the top 5 values. Now let's proceed and learn the final thing in this video, which is about looping row by row. And for that you can use something called dot iterrows. Okay. So let's go ahead and take a look at that. Now, before we take a look at the syntax for that, what would be a simple business case where you may want to loop row by row? It could be something like checking each order to see if it exceeds a certain threshold, and maybe you want to perform some custom logic on such rows. However, when you want to do something like this, we usually prefer vectorized operations in Pandas, but let's see more of that later. Now over here, let's first learn about the dot iterrows function. Okay. So again, let's see how this works. So I have the df underscore orders. Now let's just go ahead and write it, and as we write it, we can discuss it. So I can say for index comma row in df underscore orders dot iterrows. Okay. So again, what does this mean actually? Let's also try to understand that. Clearly, it's a for loop, and index over here gives us the row indices 0, 1, 2, etc. And row over here gives us a series object. Remember, a series is another data structure that we have discussed, which is there in Pandas. So a row gives us a series object representing a particular row's data. Okay. So we are going row by row, and row over here will give us the series object representing the data of the row at a particular index, and then we will be going from 0 up to the last index in the current data frame that we are considering, which is df underscore orders. So that is what this line over here does. And then let's say we want to check whether the price is greater than 100. So over here I can say if row, and I'm using bracket notation to access the value in that particular column, which is price. So if row at price is greater than 100, then let's say I want to print something. Let's say I want to print big spender alert. Okay. And then I also want to provide the order ID. So I can say order, and over here I'll say, this is blocking the screen, right? So over here I'll say row at, and again I'm using the bracket notation to access the order ID. And let's say we also want to mention the price over here. So I can say price, and again I can say row at, and I'm using the bracket notation to access the value in this particular column price. And I have to move this over here. All right. So in this way, let's run it and see what happens. Okay. So ideally we would want this statement to be printed for every row where the price is greater than 100. So let's see whether it's working. So yes, you can see over here you have 120 for this order, 127 for this order, and it goes on in this manner, and you have the output over here. Now remember, this can be slow if you have thousands or millions of rows, and Pandas' strength lies in vectorized operations, and a vectorized operation is where you do something on a complete row at once. Like over here, instead of iterating row by row, you could just do df underscore orders, and over here you can mention df underscore orders where the price is greater than 100. Okay, so this is an, again I to mention it over here, the price is greater than 100. Okay, so this is a vectorized operation because it's doing this on the complete column. Okay, or in other words, a vectorized operation in Pandas means applying an operation to an entire column or data frame at once rather than looping through individual rows manually. This takes the advantage of NumPy's optimized low level C functions, making it much faster and efficient. All right. So again, more of that later, but over here I'm just introducing this because we had an interesting scenario. And again, let's just quickly run this, and you can see that you get the same thing over here. Okay. So for example, you have this price which is greater than 100. Now again, there can be numerous cases from a business angle where something like this may be required. Like let's say we are sending a personalized thank you email to any customer who spent over $100. So you could do this either using .iterrows, which is a straightforward way, or you can do it more efficiently with a direct Boolean filter, which is what we did over here. Okay, but again, we'll discuss this probably in a future video in greater detail. Now, in this part, again, quickly reviewing this, what this does is we're going through every row, and if this condition is true, then we are printing this. Okay, and we are using the bracket notation to access these respective column values for the row that we are at the moment, because index will go from 0 till the last index of the data frame. And that brings us to the end of today. Now, quickly thinking through what we learned today. First, we used .loc and .iloc. Okay, so let's take a look at that. So we had .loc and .iloc to quickly filter for a particular order ID. Let's say we are able to access the details and we are able to inspect whether the customer complaint is true or not. Then we proceeded and we found the top 5 orders, right? So we did that over here. And then we learned about accessing columns using bracket notation as well as the dot notation, which is what we have over here. And after that, we proceeded and we checked the top 5 orders. We sorted by the price, okay? That's what we did over here, and grabbed the first 5. Management probably can now see if these are special corporate clients or if we need to investigate suspiciously large transactions, right? So quite handy. And we also saw how to use at and iat to access a specific value. Let's take a quick look at that. Where was that? That's over here, right? So we have .at and .iat over here. And finally, we also saw how to use iterrows over here to loop through the data frame row by row. And again, what we did over here was we tried to identify rows where the price was greater than 100. Probably we may want to follow up with an email or a special coupon for these loyal customers. Awesome. And that's a wrap for today. That's it for day 3, folks. Now you can confidently home in on specific rows, search for large orders, and do some quick row by row operations. As always, if you found this helpful, hit that like button and subscribe for more tips. See you in day 4.